Hi Year 8, welcome to lesson number 5 on energy transfer. And today we'll be going to be looking at radiation, thermal transfer via radiation. When you have completed this lesson, go back to EduLink and there is a worksheet for you to do, which you will need to email to the teacher setting your work, which will either be myself, Mrs. Walker, or Miss Franklin. If you are at all uncertain about what we are doing, or you need to back up your learning from today's lesson, you can go to the online books on caboodle.com, and it is pages 146 to 147 of Activate 2. By the end of today's lesson, you should be able to describe sources of infrared radiation and explain how infrared radiation is transferred. Okay, let's kick off with a bit of a quiz. An object at rest on top of a shelf is going to have more of which type of energy store? Which type of energy transfers require particles? What type of energy store is stored in a wind-up toy? That is the mechanism, the wind-up mechanism of the toy. Number 4. Thermal energy is transferred by conduction from the hot end to the cold end, or cold end to the hot end. Pause the video if you need more time to answer these questions. More gravitational potential energy. Conduction and convection require particles to transfer thermal energy. The type of energy stored in a wind-up toy, you have to think about what is being wound up, and it will have elastic potential energy. Thermal energy is transferred by conduction from the hot end to the cold end. Remember, energy always goes from a high energy to low energy until equilibrium is reached. Let's look at infrared radiation. You'll need to make some notes now. So infrared radiation travels in waves, and this is also these waves are also known as rays. An infrared radiation will travel out from a hot source in all directions, so is emitted in all directions. Notice that I'm calling it infrared radiation. Thermal energy that is conducted through radiation is called infrared radiation. If you need more time to make notes, please pause the video. So many objects which emit thermal radiation will also emit light. They glow. For example, the sun or coal, and depending on how hot it is depends on the colour that it glows. So infrared radiation is also called thermal radiation, and it's also known as heat. But for the purposes of your course, we are going to call it infrared radiation or thermal radiation. We do not want to refer to it as heat energy, because heat energy isn't as scientific as thermal energy or infrared radiation. The sun emits lots of different types of radiation, including light and infrared, and they are part of the electromagnetic spectrum. The electromagnetic spectrum also includes microwaves, radio waves, gamma waves, X-rays, and ultraviolet. And you will be learning more about that as we go through school. So some key points now for you to note about the energy transfer by radiation. If you require more time, please pause the video. So radiation is thermal energy. It travels through waves. it does not use particles. It is very different from conduction and convection, and this is very important that you remember this. Radiation travels in waves. Conduction and convection both require particles to transfer energy. So, thermal energy from the sun travels to Earth by radiation. In space, there are very few particles. We say there are no particles present, but there are so few and they are so far apart that it's inconsequential, which means that thermal energy or energy cannot be transmitted through conduction or convection. It has to be through infrared radiation or other sources of electromagnetic waves. I'm going to show you some images over the next few slides that have been taken using a thermal imaging camera, an infrared camera. These are frequently used by search and rescue teams when they go to earthquake sites or disaster sites where people may have been buried alive, and they're able to find the bodies under the rubble using these cameras. The police also use these cameras when they are hunting criminals that are escaping from a crime scene or from somewhere else. They're able to use them in their helicopters and shine them over an area, and they can then see where their warm bodies of the criminals are. Have a look at these slides. So here we have a child's hand holding a lizard. The hand is much hotter than the lizard because the lizard is cold-blooded, and the hand of the child is warm-blooded. So you'll notice that the reptile comes up as purple. Hot cup of coffee, which is white hot, and one that is cooling down, which is not so bright. This shows an injury on a person's leg. They have injured their knee. The location of the injury is much warmer due to the increased blood flow to the area, and when you fall over, your body tries to repair itself by sending more blood to the area that contains immune cells, such as white blood cells. This is a car tyre that has been, well, a picture of a tyre that has just stopped running, on the car that's just stopped running, and you'll notice that the surface that touches the road is glowing, and this is due to friction. Remember, if you rub your hands together, friction will generate heat. A gas ring on a cooker. You can quite clearly see the hotter parts there. And then we have an infrared picture of the globe taken from space. I think that one's pretty cool actually. You can definitely see where the equator is by the red, and the colder areas such as the Arctic and the Antarctic. So these are used to track surface temperatures and predict weather patterns. You can see England quite clearly there in that pale blue area, sort of like in the top third in the middle. So, time to make some more notes. Dull surfaces or matte surfaces are much better at absorbing infrared radiation than shiny surfaces, and this is because on a shiny surface the infrared radiation will be reflected, whereas on the dull surface it will be absorbed. So, looking at the two metal blocks, which one will heat up fastest? Write your answer down, pause the video if you need to. And my next question, if you lived in a hot country, what would you paint your house? Would it be a light colour or a dark colour? So if you've been on holiday to the Mediterranean, have a think about what colour houses you saw. Think about the colour of the place at school as well. So let's go through those answers. Well done. If you said that the dark block will heat up faster, you were right, and that is because it absorbs more energy. If you lived in a hot country like Spain or Greece, you would paint your house a light colour, such as white, so it will reflect the thermal energy and your house will remain cooler. So, as we've just said, dark surfaces are better emitters of infrared radiation than shiny surfaces. So a shiny surface will reflect the heat, whereas the dark surface will absorb it and then emit it. So it's slightly different. So light and thermal energy will be reflected from a shiny surface, whereas a dark surface or a dull surface will absorb the energy. The energy will build up within the dark surface, within the dark object, and then it will start to emit it. So which will lose heat the fastest? Will it be the cup of tea in the shiny cup, shiny inside and out, or will it be in the dull cup? If you had a food delivery business, would you deliver the food in dark coloured containers or aluminium foil? You think about the takeaway that you might get from the curry house if you're lucky enough to get takeaways. They always seem to come in foil containers, and this is because heat will be reflected inwards and keep the food warmer. The dark surface would absorb the heat and then emit it outwards. We have copied this link onto EduLink. Please pause the video and click on EduLink to watch the YouTube clip. Time to make some more notes. This is how a vacuum flask works. It has a double wall of silvered glass with some vacuum between the wall. Remember, the air is a very poor emitter of thermal energy, or a very poor conductor of thermal energy, so it's acting like an insulator. The silvered surfaces will reflect the infrared radiation for the very hot contents back inside the flask, and the vacuum between the outer and inner walls prevents heat loss through conduction. This could come up as a 6-mark question. Explain how a vacuum flask works. And you would need to have, to get 4 marks, you would need to have that the flask had a double wall, a reflective surface, and the vacuum between the two outer surfaces prevents heat loss, because air is a poor conductor. Let's do a quick quiz. What direction does radiation travel in? Think of that first slide and the image at the bottom of it. Which will radiate more heat? A black surface or a shiny surface? Which will absorb more heat? Pause the video if you need more time. Let's go through those answers. So, radiation travels in all directions from the object in all directions in a straight line. Remember, it travels as a wave in a straight line. Which will radiate more heat, black or shiny surfaces? Well, it's a black surface. And it also absorbs more heat. What's the other name for heat radiation? Infrared. Give two uses for this radiation. You could have had so many different uses. You could have had infrared photographs, remote controls, heat-seeking missiles, thermal imaging cameras for searching for survivors, chasing criminals. We use radiation to cook, and we also use it in our homes to keep warm. Think about our radiators. They emit radiation. So let's just summarize in this picture the three methods of thermal energy transfer. First of all, we have conduction, that is particles next to each other passing on thermal energy. Then we have convection, particles creating a convection current when they are heated, rising from a hot area to a cool area, then cooling, falling and then being heated again, so forming that convection current. And then we have infrared radiation, which is thermal energy being transmitted via waves. Just to clarify. So you should now be able to describe some sources of infrared radiation and explain how energy is transferred by radiation. Please now complete the worksheet that has been set on EduLink, and we will see you in the live lesson later in the week. Bye.